All right, so we're in section 5.1, Introduction to Random Variables and Probability Distributions. So what are random variables? Quantitative variables that take on values due to chance, like tossing a coin, rolling a die, drawing a certain card out of a deck of cards. So this is divided into two types of random variables. The first that is covered in your text is discrete random variables. It takes on a finite or countable number of values. For example, numbers of students in a class. Then we also have continuous random variables that take on any value on the interval of real numbers. For example, height of students in a class. Probability distribution. The definition of that, an assignment of probabilities to the values of random variables. Each value of the random variable has a probability assigned, and the sum of all probabilities have to add up to equal 1. And this distribution can be graphed in the form of a histogram, which I will show you later on in this presentation. Here's an example of a type of distribution. It's actually a binomial distribution. You're tossing a fair coin 3 times. And so a fair coin, it's going to be 50% or 0.5 that it comes up heads and 0.5 that it comes up tails. So let's consider H equals heads and T equals tails. Let the event of interest be the number of heads. So we're tossing a coin 3 times, right? So you can either get 0 heads, 1 head out of the 3 tosses, 2 heads out of the 3 tosses, or all 3 heads. So these are the ways it can happen. The way you get 0 successes, if you will, we're interested in the number of heads. So tails would be considered a failure. But anyway, you can have 0 heads, which means you got tails on all 3 tosses, which means the probability of R equals 0, which means the probability of T, remember each toss of a coin is one half, right? So 1/2 times 1/2 times 1/2 is 1/8, or 0.125 if you want it decimally. The probability you get exactly 1 head, you could either get a head, a tail, and a tail, a tail, a head, and a tail, or a tail, and a head. For what we're considering successes here that you get a head, you could get a head, head, tail, head, or tail, head. Or you could get all 3 heads, in which case X would equal 3 for all 3 heads. So how do you calculate the probability? Well, again, we went over the probability of R equals 0 successes. It's all tails is 1/8 or 0.125. The probability R equals 1, 1 success out of the 3 tosses. It's the probability of a head, tail, tail, or a tail, head, tail, or a tail, tail, head. Well, or, of course, as we saw in a previous probabilities section, meant that you're using the addition rule. So that's the probability of head, tail, tail, plus the probability of tail, head, tail, plus the probability of tail, tail, head. Now, in the way that your book has it, P are the successes and Q is the failures. So that's going to be 3 times P, the probability of success, times Q squared, the probability of failures, because you get 2 tails in each of these. So that's 3 times the probability of success, 1/2, times the probability of failure, 1/2 times 1/2, which is 1/4, is going to equal 3/8 or 0.375. The probability that you get 2 successes, that's the probability of a head, head, tail, or tail, head, head, or head, tail, head, Well, again, or means addition here. So we're doing the probability of a head-head-tail plus the probability of a tail-head-head plus the probability of a head-tail-head. So your number of successes in each of these are h times h, which is q, p squared, excuse me, times q, the probability of failure. So that's 3 times the probability you get 2 heads is 1/2 times 1/2 or 1/4. Q, considered the probability of failure, is 1/2 the probability that you get a tail. So multiply this together, you get 3/8 or 0.375. The probability it's all heads, the probability your successes equal 3 is the probability you get a head-head-head. That's 1/2 times 1/2 times 1/2, which is 1/8 or 0.125. I'm going to show you other ways to calculate this using the graphing calculator and an appendix that's in the back of the textbook. And all of these probabilities have to add up to 1, right? Notice the 0.125 on either side. We'll look at this when we graph a histogram. And then the probability of 1 or 2 successes is 0.375. So our histogram that we see is going to be a symmetrical histogram. So actually, yeah, well, anyway, note that this distribution can be graphed as a histogram, which I just mentioned, with the horizontal axis x and vertical axis p of x. So take a look at figure 5-1 on page 185 when you get a chance. The mean and standard deviation of a discrete probability distribution is discussed on page 188. Mu, the mean, is also referred to as expected value. That's the mean of a discrete probability distribution where mu equals the sum of each x times p of x value. Sigma, the standard deviation of the discrete probability distribution, is the square root of the summation of, in parentheses, x minus mu squared times each p of x. Now, this is important because I'm about to show you this with the previous data. This can be done on the TI calculator similarly to the weighted average and grouped data. So we've seen this before. Single var stats L1, L2. Your outcomes X are going to be in list 1. The corresponding probabilities P of X are going to be in list 2. And take a look at the calculator note on page 188. In fact, as we're going through the entire course, anytime you see something that you can learn how to do on a graphing calculator, look over those notes on how to do that on the graphing calculator. All right. So let me backtrack a little bit here. And in fact, I'm going to pause this while I change the view here. All right. All right. There we go. Popped out of the way. So let's take a look at calculating these probabilities on your graphing calculator. We've already done something like this before, so this should look familiar. Single var stats L1, L2 is what we're looking for. So we're going to go to stat. Under edit, we want edit. It's already on that. I'm going to press enter. Now, to let you know, I've already entered the data. So on list 1, you want the X values, the number of successes, 0, 1, 2, and 3. Under list 2, you want the corresponding probabilities, 0.125, 0.375, 0.375, and 0.125. And we'll look later at how you can actually calculate these values, which is going to run into what you're going to see in section 5.2. All right. But anyway, we enter the data. I'll do second quit. Then we'll do stat. Under edit, we want option number 1, which is edit. It's already there. We'll press enter. Oops, not edit. I'm sorry. Stat calc. My bad. We want calc, not edit. We want single var stats. Press enter. L1 is over the number 1, so press second L1, or press second 1, and you'll get list 1. Then comma, second 2 gives you list 2, and then just press enter. Here's the mean of that deviation standard, or here's the mean of this distribution, 1.5. And here's the standard deviation for this distribution, let's say approximately 0.866, right? So that can be done on your graphing calculator. All right, and speaking of graphing calculator, let's take a look at the histogram of this particular experiment. So above the y equals key, you'll see stat plot, which we want to access. Go to second, press the y equals key. Now, I already have plot 1 turned on because I've looked at this and we've used it previously. So let me just do this. If your plot is off, arrow over to on, press enter, turn it on. Go down to type, and we want the histogram, which is this third one here on the top. So go to that and press enter. Arrow down, actually, let me do this from scratch. Oops. Because I want to do this with it turned off, and then we'll turn it on. So there's that. All right, so we'll go to second stat plot. We'll press the enter, we'll hit on. All right, and then you'll go down and arrow over and select the histogram, okay? And then go down, your X list is going to be L1. For your frequency list, press the second and number 2 to get L2, okay? Then I'll quit, second quit. So we're doing a histogram of this particular data, which is going to be symmetrical, right? Then we're going to go to graph. Now check this out. If you graph the data, here's something important. You want to make sure you can actually see it in your window. So rather, you could mess around with it. I ended up doing this, messing around with it here, but you could also do zoom, hit the zoom key, and then I think it's closer if you go, or quicker if you go up rather than down. You want zoom fit, which is option 0. So you could press enter for that, and it should give you a good fit of the data. Now let's go to this trace key right here, and we'll hit the trace key. That's the minimum that I have on my axis right there. But if you arrow to the right, that gives you the minimum, which is 0 successes, X is 0. And then notice that it gives you the 0.125, which is the probability of 0. Arrow again to the right, you get the minimum is 1 success right here. And notice it's 0.375, just like if we were to do it by hand, essentially, on the chart here. One more time, you get 0.375, go again to the right, you get that last, all 3 successes with a probability of 0.125. All right, so another way to do this, I'm messing around with it here to make sure I'm getting it right. Above the vars key, you'll see DISTR, which is distribution. So if you press second vars, it gives you different types of distributions where you can calculate probability. Later on, by the way, when we get into chapter 6, normal probability density functions and cumulative density functions, that's what the PDF and CDF stand for. When we're using normal distributions, we'll be using 102 or options 1 and 2 under distribution. I find it's easier if you go up, quicker to go up. Let's find binomial PDF. And so what we're going to press or what we're going to type is the number of successes total that we have is 3 times. So that's going to be n, comma, the probability of each success, each time you toss it, the coin is 0.5, and then comma, these are your X values. This is actually, I read it NPR as the number of successes, even though here, and National Public Radio helps me remember it. These are called X's here, okay? So on the chart and in your textbook. So let's say what's the probability that you get a 0 out of the 3 tosses? No heads, all tails. Close the parenthesis, press enter, 0.125. What's the probability you get exactly 1 success? Let's try it this way. Let's do second. Well, you could go through that entire process again, or just press second enter and pop it back up and go back and change that 0 to a 1. There's our 0.375. And then you could go on and do the same. Actually, let's go on and just finish this out. Let's change the 1 to a 2. You get enter 0.375. Second enter, let's change the 2 to a 3 where it's all 3 heads, all 3 successes, and you get the 0.125. So you can also calculate the values rather than doing it by a table like this the long way on your graphing calculator. All right, another way that you can get these probabilities is from a table of binomial probabilities in the appendix. So here's your understandable statistics book under your T books. So if we go all the way down, so I was in chapter 5, right, looking over stuff, but go all the way down to appendix 2. I'm going to click on that. And so what we want are the binomial. All right, so we want table 3 is what we're going to take a look at here. So let me just, oh crap, I hit the wrong one. Hold on, let me pause. All right, so we're back here in appendix 2, and what we want is the binomial probability distribution. So let me arrow down to that. Table 1, by the way, is random numbers, like the random number tables that we talked about earlier in the course. We'll skip over table 2. Here we go. Table 3, binomial probability distribution. Now I'm going to click on this and make it bigger here so we can see it. And zoom in. Wonder if I can go a little bit further. Yeah, let's try that. All right. So this is strictly a binomial distribution table. All right. So what you do is showing the probability of R successes in N independent trials, each with the probability of success of P, right? So if down to or if we go over at the top, these are the probabilities going across the top. We go down to 0.5 because when you're tossing a coin, the probability is 0.5 that it's heads or tails. And we wanted three successes. R is the number of successes, right? And so go down this N to 3, and then go across and see where it intersects the column of 0.5, and you'll see those probabilities pop up here. So here's the probability of 0 successes, okay? 0.125. The probability of 1 success, you get 1 head, is 0.375. The probability of exactly 2 heads is 0.375. The probability of all 3 heads is 0.125. So you could also use this chart that's in the back of your book in Appendix 2 when you're calculating binomial probabilities. All right, so what I would like you to do, take a look at guided exercise 1 on page 184, take a look at example 1 on page 185, guided exercise 2 on page 185, example 2 on expected value, standard deviation, pages 185 to 188, and guided exercise 3 on page 188. And then here's the recommended homework. Problem number 1, 3, 7, 13 parts C and D, 15 parts B, C, and D. And I don't know why I have an and 3 there, so forget the and 3. So 15 parts B, C, D. Oh, that should be an E, that's why. Let me change that. B, C, D, and 3. Sorry about that typo. All right, so there you go, 5.1. Take a look at that, and I'll talk to you later.